Okay, friends, so you just got to watch, what was it, 18 total games? If you count Magic and Peyton as the first, you saw 17 more, so 18 total games. Those 18 games represented a small smattering of everything that could happen in Russian egg roulette, assuming that it's been played more than 18 times. And conveniently, somewhat conveniently, 6 of the 18 games had the first person draw a raw egg first, which exactly corresponds to the 4 out of 12 that we got in that previous video. Okay, now if you're like me, you want to see more trials. Jimmy Fallon doesn't have any more posted, but what I did was I just simulated the experiment in Excel. I do this all the time, you know. And I've got a 12 egg carton here, 12 egg carton. And every time I can re-randomize it, I can move the raw eggs around and the hard-boiled eggs around. So this is creating a new carton each time. I can just hold it down and let it go. And, you know, fantastic. Still a little bit fictitious, though. Still a little bit fictitious because, again, I can see all 12 eggs. I don't want to see all 12 eggs. Statisticians aren't going to see their population. They're going to see a sample from their population. So what we're going to do instead is focus, I don't know if you can see this egg that's right here. I've got that black border on it. We're going to focus just on that egg over here. So that one now, if you take a look at it, is either hard-boiled or raw. But now we more realistically see that we can't observe the entire population. So all we're observing is a sample drawn from the population of all these eggs going, flipping back and forth between hard-boiled and raw. Now that's a little bit fast. Let's slow it down. If I do this, you might observe something and say, huh, it looks like, man, it's hard to tell, actually. It's hard to tell. Is it 50-50? Are we getting raw half the time and hard-boiled half the time? Man, it's really hard to tell. Maybe what we should do is look at some cumulative data and help us answer that question. So let's move over here. Okay, so now here in this chart, I'm going to keep track of how many times egg number 3 was either raw or hard-boiled. Right now, I've seen 1 hard-boiled and 0 raw. I reset the numbers. If I press it again, that time I saw another hard-boiled one. If I press it again, another hard-boiled one. Hard-boiled, raw, hard-boiled, hard-boiled. Okay, so you're starting to see that, well, you know, it looks like we're getting more hard-boiled than raw. Again, in reality, you don't know how many eggs are in the carton or items are in the population. All you get to see are your samples that you draw. But right now, it's starting to look like we're seeing more hard-boiled than raw. I'm going to hold this thing down and let it play out while we chat a little bit more. So yeah, you can totally see it now. After we've played this experiment a couple hundred times, and what I'm going to do out here is I'm going to back out this window a little bit so you can actually see the empirical probability. I call this empirical probability because it's not a calculation. We're not calculating that 33% and that 67%. Oh, it's fighting. Now it thinks it's 34 and it's fighting back and forth. It thinks it's 34 and 66, 33, 67. I'm going to let it keep playing while we're talking. It's empirical because we don't have that 4 out of 12 that we had in the last video, right? In that last video, we knew there were exactly 12 eggs. 4 of them were hard-boiled. Here, we don't know that. All we know is we get to see the result. This is kind of cool, actually, what's going on right here. Did you notice that? It was jumping up to 35 and 65 for a little bit. Looks like it had a little run of raw eggs in there that drove up the probabilities, and now it's sitting at 34 and 66. I'm going to let it keep running while we're chatting here. Because what you're noticing is the long run probability is now beginning to stabilize at right around, it's saying 34% and 66%. The longer we run this simulator, the better the result of the resulting probability we're going to get. Now, in reality, statisticians don't get to just run these simulators indefinitely and see what happens. They have to stop at some point, so I'm going to stop right here. And they have to say, okay, my empirical probability of a raw egg is about 34%, which means the hard-boiled probability is about 66%. That's great. Now, you might say to yourself, yeah, but we just calculated the probability theoretically was 33%, not 34%. Correct. And if you've had Math 105 or previous probability studies before, you'll know that there's a slight difference, usually, between a theoretical probability and an empirical one. I'm going to talk about that a little bit in the next video, and then I'm going to set you loose with the assignments for this.